Alright, today we're going to talk about our application of quadratic equations. So with most word problems, the hardest part is just figuring out what it's asking for you to do. I like to draw diagrams or pictures if possible, and then make sure you're answering the question that's being asked. So I usually read the problems a few times just to make sure I'm understanding what we're supposed to do. But here what we need to do is find the dimensions of a rectangle if the length is one more than 3 times the width. You can use whatever variables you like. I like to say the length is 1 more than 3 times the width. So I just go through and I translate it exactly as it says. And the area is 154 square feet. Well, for a rectangle, area is length times width. So when I draw a diagram, I know that this would be my length and I know this is my width. So don't forget your width on here, and your length, you're going to substitute into that. Alright, so now you're going to have your width times your length, which we said which was 3w plus 1, and then you'll get 3 squared plus w equals 154. Now, since we're solving, let's go ahead and subtract 154 from both sides, and you'll get 3w squared plus w minus 154 equals 0. And then you can go ahead and you can factor this, you can do the AC, but we know that's going to be pretty big factors to get that. So I know 3w is going to be 3 and a 1, and then 154 we broke into those two there. Alright, so now I'm going to set this equal to 0, and then I'm going to set this equal to 0. And then once I've got that, I have w equals negative 22 over 3. Well, that doesn't make sense to have a negative for a width, so we can't do that one. But we can add 7 to get plus 7. So this does work. And then now we know w is 7. Now you just substitute it in, and you go 3 times 7 plus 1. And that's where we got the 22 from. Alright, so then finally, it wants to know the dimensions. So we know we answered the question being asked. Alright, this picture is a little more complicated. So he's going to make an open top box by cutting equal squares from the 4 corners of an 11 by 14. So the open squares are these parts right here. And then we know that it's 11 by 14, and folding up the sides. If the area of the base is to be 40 square inches, what size square would be cut from each corner? So we know area is length times width. Now, if I know this side is the whole side is supposed to be 11, I don't know. I know it's a square, so I know all the sides are the same. So for area, I know those will be x. And if they're all equal squares, I know this is x. So this whole side is 11. So we're actually going to take 11 minus this guy and that guy, which will give you the blue. We're going to do the same thing here. If the whole thing is supposed to be 14, but we cut this part from it, I know that this portion right here is actually 14 minus 2x. So now we can go through, and we said that the dimensions, the area of the base should be 40, so we're going to equal that to 40. So I'm taking this times this, and then you're going to distribute, and you'll get this down here. Combine your like terms. So, and I just kind of flip-flopped the area here. And then subtract 40. So I subtracted 40 from here and got 114. Okay? So now we can go through, we can take this, factor out the GCF, and you're left with 2x squared minus 25x plus 57 equals 0. Then you can go through and you can do your guess and check, or you can do your AC method, whichever way works best for you. And I know that this is going to group together to give you 2x minus 19 and x minus 3 equals 0. Don't forget to bring that down. And then you're going to factor, set them both equal to 0. Well, I know that I can have 19 over 2, but that doesn't quite make sense because when we plug it in here, we got to check for extraneous roots. So what I did is I plugged it into here, and when I got that, I got 11 minus 2 times 19 squared, so that's going to be 19. When I did it, I'm going to get a negative 8. I can't use that, so I'm not going to use that one. So now we're going to check this one to see if it works, and in this case, it does because you got 11 minus 6, which is positive 5. So I know the square, I know it should be, these squares are each going to be 3 by 3 inches. Now number 3 is similar setup, so I at least drew a picture for you, but then you can go ahead and find the rest. And then for number 4, you've got a yard, 25 by 30, that's surrounded by a walk of uniform length, or width, excuse me. If the area of the walk is 30 feet, how wide is the walk? So we're basically looking for the area of the yard is 750, and I know that's the purple part. So we're going to take all of this and figure out what the area of the walk, or excuse me, the other part, because we know the area of the walk is 300. So just remember, if we take this side, we're taking x plus 30 plus x. So you get 30x plus 2, or 30 plus 2x. And this side, we know it's x plus 25 plus x. So that's where we got 25 plus 2x for that side. And again, multiply, distribute, and I got this. I'm going to combine like terms, and then don't forget the rest of this information mine here. So we're subtracting the yard, so we're basically taking the whole thing, and we're subtracting that part, and then that equals the area of the walk, okay, which is 300. So these two cancel each other out. And then I'm left with this part, and now I'm going to subtract 300, and I'm left with 4x plus 110x minus 300 equals 0, GCF. And then go ahead and you can factor however you choose, and break this apart into 2x minus 5, x plus 30, and don't forget that 2 up front. And then once you're done, you're going to set them equal to 0 and solve. So one part could be 5 halves or 2.5 feet, and then here we've got a negative 30, so we can't do that one because it's a negative. And then, so that would be the final answer here. So all we did was take the area of the walk minus the yard, or the big one minus the yard, and that gives you the walk. All right. This one is a hypotenuse of a right triangle is 17, so I drew my right triangle here. Here's the hypotenuse. The long leg is 7 more than the short leg. So long leg is 7 more, so this is your long leg. And then your short leg is just x. So we want to find the base and height of the triangle. So we can use Pythagorean theorem. So we can go a squared, or we can go a, b, c. And this would be a squared plus b squared equals c squared. But just be careful, when you're squaring this, it's really 7 plus 7 times 7 plus 7. So distribute, and you're going to get x squared plus 14x plus 49. Bring the rest down, combine like terms. And then we're going to subtract 289. You're going to get negative 240. And then now you can go through and you can GCF. And then go ahead, factor how you choose, and you should get 2 times x plus 15 times x minus 8. So them all equal to 0. Well, you know when you sum them equal to 0, you can't have a negative length, so you can't have x equals 8. So that one is your answer there. Okay, I want you to try that one. It's kind of similar to this one. If you did it, just make sure you're checking your answers. Oh, I almost forgot to put the second part here. So now that I know x is 8, I have to plug this in 8 plus 7. So your long leg is 15. So here's your answers here. Alright, so just make sure you're checking this one, but this is asking to find the area of the triangle. Alright, consecutive integer patterns. When you're doing this, remember your first number is n, and you're just adding 1 to each number after. So first is n, second is or x, and second is x plus 1. So I want two consecutive positive integers. So the sum of the squares is 421. So this squared plus this squared equals 421. Alright, and just remember, this is x plus 1 times x plus 1, and distribute, and you're going to get x squared plus 2x plus 1, combine like terms, bring the rest down. We're going to subtract 421, and you're going to get negative 420, and then now factor 2 out, and then here factor this how you choose. You're going to get x plus 15, x minus 14, set them both equal to 0. You'll get x equals negative 15. Well, you can't do that because we want a positive integer. So we're going to have x equals 14. So if the first number is 14, we know that 14 plus 1 is going to give you 15. Alright, and on this one you have 3 consecutive positive even integers. So here's the rules. Remember your first number, then you got to add 2 to get to the next one. Add 2, add 2. Alright, so it says the product, so you're multiplying, of the first integer, this one's the first, and the third integer, this one's the third, is 192. So multiply these together, and then you're going to subtract 192. And now go ahead factor, and you'll get x plus 16 and x minus 12 equals 0. Set this equal to 0, that equal to 0. You're going to get x equals negative 16. Well, it says positive, so we can't do that one. So we're going to take 12, and we know the numbers would be 14, 12, 14, 16. Alright, so that is just the application of quadratic equations. Remember to draw pictures if it helps, and then make sure you're answering the questions being asked, and make sure you check for extraneous roots, or to make sure you're following directions to know that you're putting in the correct information for the final answer.